Go.
Okay, good. Woo! Hello, class. Finishing up this problem because I really want to. Here's what we did. We had this function. We factored the numerator, we factored the denominator, we made the sign chart for it, we realized what the roots were, what the vertical asymptotes were, and then we talked about the end behavior. And then what we didn't do is graph it yet. Maybe we can do that. A couple more small things that are worth doing. Of course, I can always plug in 0, and if I plug in 0 on the top, I get -3, and the bottom, I get -2, so that's 3 halves. So that's kind of nice because it tells me that the y-intercept of 0, 3 halves. All right, now I'm going to go to graph this, and I'm going to sort of try to graph it, and then I'm going to hopefully sort of prove a point or something about what's going on. Well, all right, what does this graph look like? Let's put in some thingies. Boom, 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 boom. All right, well, we agreed that there was a vertical asymptote at y equals 1. I didn't write that down, but I will write that now. Vertical asymptote y equals 1. That's because the end behavior is 1 in both directions. So I'm going to add that in. That's just what we mean by that. So we got a little... And then also, there are roots at -1 and 3. So here's a root at -1, and here is a root at 3. And there are vertical asymptotes at 1 and -2. So here's 1, and here is -2. Okay, so all of that was pretty straightforward. But now, if I go to graph this function, I find myself not knowing exactly what to do. Because here I am looking at this sign chart. What do I know? Well, I know that my function, when x is like -1,000,000, I know that it's very, very close to y equals 1. But is it just above y equals 1 or just below? I'm not really sure. And here, this doesn't tell me because all this tells me is that I'm positive. Okay, so knowing that my function is positive to the left of -2, what happens at -2 is my function blows up. It becomes like infinite. Which kind of infinite? Positive infinite. So what I can say for sure is this. But what I can't say for sure is there are really two options. This is one option, that it looks like that. But there is another option. And the other option is that the function will cross its asymptote. And will look maybe instead like this or something. Now, before you say that that can't happen, I want to just dispel that myth right now, that all we mean when we say that there is a horizontal asymptote is that the end behavior is 1. There's nothing that says that a function can't cross its horizontal asymptote. In fact, functions cross the horizontal asymptotes all the time. That's a misunderstanding. So, not knowing which one of these it is, how can I answer this question? Let's suppose that I care about that. Let's suppose that whether a function crosses its horizontal asymptote is something I care about. Then there is a solution, and the solution is polynomial long division. So the thing, just as the bell was ringing, I was saying to do was polynomial long division. This function is begging to be divided. It's basically saying divide me. So let's follow the directions. X squared minus 2x minus 3, and we divide by x squared plus x minus 2. Okay, that goes in one time, and we get x squared plus x minus 2. And then I subtract, and I get -3x plus 1. Okay, so that means, and here's like a sort of a powerful and important step. That means that this function just is the function 1 plus -3x plus 1 over x plus 2, x plus 1. Or rather, x plus 2x minus 1. Okay, what does that mean? And I'm going to put a sort of a box around this because this is very important to me. Two things that I learned from doing this polynomial long division. One thing I learned is that I'm sort of more confident now or something about the fact that this is my end behavior. Because here I can see at a moment's glance that when x is very, very big, that this is a linear over a quadratic. And this quadratic will dominate this linear function. So for a huge x value, this remainder stuff is pretty much 0. So this kind of, to me, this shows that the end behavior is 1. But the other thing that happens is I can see now at a glance when my function equals 1. When will my function cross this line, y equals 1? Well, this function will cross the line y equals 1 when f just is 1. And what is f? Well, f is 1 plus some stuff. Therefore, the only time f will cross is when that stuff is 0. and the only way for that stuff to be 0 is for the numerator to be 0. And there's only ever, well, now it's just up to you to figure out when is negative 3x plus 1 0, and the answer is negative a third. Okay, therefore, if I plug in negative a third, then I just get negative 3 times negative a third is, no, sorry, positive a third, I meant to say. If I plug in positive a third, then I get negative 3 times positive a third is negative 1 plus 1 is 0. Okay, so once I know that f of a third is 1, then I have another point that I can add to my graph. That other point is this one right here, 1/3, comma 1. So that's 1/3, comma 1. And what else did I have? I took out the y-intercept. So when I plug in 0, I get 3/2. So that's another point, 0, comma 3/2. And now I have an answer to my question from a minute ago. Which is it, the purple or the green? Well, it has to be the purple, because I see that my function cannot cross the line y equals 1 over here. Why? Because it only crosses the line y equals 1 at one time and one time only, which is when this numerator is 0, which is at 1/3. So I can erase this. So by doing polynomial long division, I discover exactly where my function crosses the horizontal asymptote and sort of where it doesn't. All right, now that I have all this information, I can finish this graph, and I can know that to the right of negative 2, my function's like negative infinite. In between negative 2 and negative 1, my function will be negative, and I have a root at negative 1, so it looks like that. Something went wrong. Oh boy. What went wrong? 1/3, wait. Let me just double check something here. Negative 3 minus negative 2 is negative 1. Oops. Okay, that was a good example of finding a mistake because the graph made no sense. So I made a little algebra mistake here with my polynomial long division. Sorry about that. That should actually be negative 3 minus negative 2 is negative 1. So that's negative 3 minus 1. So it is actually negative a third, which gives me a thing of 1. That makes this a bad video, but I don't care. It is fixed now. That is a point negative 1/3, comma 1. And now this is making a lot more sense. My function's positive between negative 1 and 1. So what happens at 1? It blows up to positive infinity. What about on the other side of 1? It's infinite at 1, but if x is a little bit more than 1, then it's like negative infinity. It's negative until 3, where it crosses. And now, I'm going to keep drawing. And now, what is my function doing? Is it going to cross this asymptote or not? The answer is I know it's not going to cross, because I know that my function crosses the line y equals 1 once and once only. That is here at negative 1/3, so it doesn't cross over here. So it stays below this asymptote over here and it stays above the asymptote y equals 1 over here. Question?
But doesn't the end behavior need to be positive?
The end behavior is 1. By that I mean just 1, right? In fact, I have just learned, what I have just learned is that, which I didn't know otherwise, have I done something wrong? No, I think I'm
He's right. What matters is that it's approaching.
I think I'm right here. So these are both a little bit, over here, as x approaches infinity, in fact, I'm a little bit less than 1. That is not obvious at all from just our casual observation that the numerator and denominator are almost the same. It's actually something that I just learned from making the graph. And over here, as x approaches, this should say negative infinity, as x approaches negative infinity, my function's a little bit more than 1. But it's not possible really to get that just from looking at this fraction. So I learned that too. Question, or are you good? Okay, good. All right, bye. Stop.